Before discussing about the first technique mentioned, which is polling, it would be wise to remind ourselves what a regular HTTP request looks like. A client requests a web page from a server. The server calculates the response and sends it to the client, which is done through the HTTP protocol. How can we enhance this traditional transaction? By making the server able to pass data and updates to the client. The first technique is through AJAX polling. The client requests a web page from the server and the server responds. Then, through periodical AJAX requests, the client requests data from the server under the scenes. Finally, the server responds and passes new data to the user. Let us view a quick demo on how to create the AJAX polling flow. The first step is to create an HTML page. This will work as the client. The next step is to create a simple PHP page, which functions as the server. The PHP page will send the data of a file named messageboard.txt. In real production scenarios, the server can call a database for state changes, or pass updates to the user from a feed or a service. It can clearly be seen that the PHP script has only 2 lines of code. The first line accepts all the request origins, so it can send data to a client from any domain, while the second line just loads data from the set file and returns it to the client that made the request. From the client side, we can create a function called getMessageBoard and make a GET request to the server to get the data from the messageboard.txt file. Next, we will add the data into a div and set a 1-second interval that will call that function every 1 second. What happens when we run the web page? When the client made a request to the server loaded the content from the file messageboard.txt. Once the data was changed in the messageboard.txt, the data changes are reflected on the website as well. This happened because the client was requesting the data every second, so once the data changed, it was then reflected on the browser. If we check the network traffic, we can see the requests taking place every second. This occurs in order to update the data. An improvement to the first technique is AJAX long polling. AJAX requests have a property called timeout. When they start making a request to the server, they wait for a long time for a response. We will use this feature to make longer requests to the server, so once it has an update, it will send it. Then, we can open a new request which will stay open for a long time as well. As can be seen, the server-side code has already been written in PHP. This script gets the timestamp parameter from the request and enters an infinite loop. Once the file is changed, there is consequently a modification. The new timestamp of the file is reflected on the variable called currentModIf. When compared to the old timestamp, it is clearly understood that the file has been modified, and the new data is sent with the new timestamp. From the client side, we observe that we have the same AJAX request as before, but now we pass in the timestamp parameter. It is an async request and has a lengthy timeout of 50 seconds. We will therefore make a request every 50 seconds, removing a great load from the server. However, once the server has a change and returns the data, we fall into the success function, which reflects the data on the div and sets a new timestamp using the time last updated. Lastly, we call the AJAX request again, waiting for another 50 seconds to see if the file has changed. When checking the network traffic, it is clear that the requests are done more periodically. The connection is refreshed only when the data changes or when the timeout ends, which in our case is 50 seconds.